Hi, Dr. Tamiru and Dr. Wartin. We are Team UFO who is taking course MVP 4062 Mechatronics, and today we'll be presenting about our twin project Automated Water Tap System. And our group consists of 5 members, which are Zi Neng, Bong Yi Wen, Brandon Kong Zhen, Ngo Wai Ming, and me, Yeong Jian.
Good day, my name is Brandon, and today I'll be presenting to you the introduction of this project. First, let us begin with the project backgrounds. The concept of automatic water tap or water faucet was first introduced in the 1950s. It is only commercially available until the late 1980s. The demand of autonomous technologies in water tap system had skyrocketed, especially after the introductions of COVID-19 pandemic. Moreover, in recent years, the development of advanced electronic systems such as PLC and sensors had accelerated the growth of automated water tap system. Next, let us move on to the problem statement of these projects. So in this project, we have 3 problems that need to be addressed. First is the hygiene concerns, where water tap can be a potential source of infections such as the COVID-19. Next is the energy consumptions, where the current manual system requires a constant supply of energy to keep the water flowing. And finally is the water wastage, where the current manual systems of water tap often lead to wastage of water due to human error or negligence. To address the problems, we have 2 objectives. So the first is the designations, which is to design a reliable automated water tap systems that operate based on sensors and PLC. And next is simulations, which is to simulate the operations of the system using online simulation tools to prove that the system works as per desired operation. Proceeds. This is the scope of studies in these projects. So the first one is to perform research on the available prototype in the market, followed by developing evaluation metrics to determine the best designs. Next is to design a reliable automated water tap systems using programmable logic controllers PLC, and followed by to devise a set of instructions to control the system utilizing ladder diagram, and finally to simulate the operations of the system using online simulation tools.
Hi, I'm Yuan, and I would like to present the literature review of this project. First would be the hand hygiene practice in Malaysia. Poor hand hygiene is the main channel for the spread of germs and also infectious disease, and research has shown that with proper hand washing, we can reduce the occurrence of infectious disease down to 50%, specifically on the acute lower respiratory tract infections. So the World Health Organization (WHO) also urged its member countries to emphasize on the improvement of hand hygiene practice as one of the crucial steps to prevent the spread of diseases. And according to WHO and also CDC again, there are 5 steps to properly wash our hands. However, the step involves 4 times of turning on and off the faucets or tap. So when compared to manual faucets that require physical contact between the tap and also user hands, contactless electronic faucets is found to have less microbes and also reduce the chance of spreading infectious germs. However, despite there are a lot of research showing that the significance of hand hygiene, it is poorly practiced in Malaysia, either among university students or preschool children. Specifically, only about 50% of Malaysian students practice correct hand hygiene or hand washing procedure. So therefore, it is the interest of this project to design an automatic faucet that can sense the presence of hands, disperse soap, warm or cool water for 20 seconds according to the position of user hands, and switch off the water flow by the means of programmable logic controller or PLC. So for an automatic faucet to detect the presence of hand and respond accordingly, we need a proximity sensor. Infrared sensor is the most common proximity sensor that can be found in our life, such as TV, automatic door, and in our case, automatic faucet. It works on the principle of detecting invisible infrared radiations. The sensor typically consists of 2 components, which are an emitter and also a receiver, as shown in the figure below. So, the working principle of the sensor is first, the emitter emits the infrared radiations. When there is an object in front of the emitter, the object reflects back the radiations, and the reflected radiation is then received by the receiver. The receiver has a photodiode sensor, and the photodiode sensor generates an electric current when that it detects a radiation reflected back, and the current signal is then amplified by op-amp. So by referring to the reference voltage or current, there is the component named comparator to detect the voltage change and transmit binary signal either 1 or 0 to the microprocessor to respond accordingly. So the other type of proximity sensor is capacitance sensor. Different from infrared sensor, the capacitance sensor consists of a pair of parallel metal plate that is separated by a small distance. So when there's a potential difference applied to the plates, an electric field is generated and therefore causing the capacitance to exist between the two plates. So the working principle of this sensor is when the dielectric material in our faucet case is our user's hands come close to the sensor, it changes the permittivity of the plates and change the capacitance. So the change in capacitance is then converted into digital signal using op-amp and is interpreted by microprocessor to react accordingly. So next, to let the automatic faucet exhibit certain logic controlling, for example disperse water after detecting the presence of hand, a programmable logic controller or PLC is required. A PLC or programmable logic controller is a ruggedized computer that first invented by Dick Morley back in 1968 to automate mechanical process. So it can automate specific process, machine function, or even the entire production line. So it can store instructions and achieve functions such as logicking, sequencing, timing, counting, and arithmetic control to control machine or process. One of the common applications of PLC that can be seen in our daily life is the controlling of traffic light. So the advantage of PLC includes that it is able to withstand harsh conditions, versatile, and also small in size, and it is very easy to be programmed using ladder diagram logics.
Hi, I'm Wai Ming. I will be continuing on the methodology for our projects. To come with our project, we account of a total of 3 concept generations. Now, let me introduce our first design concept for the water taps. First of all, it can be controlled by using a voice activations, which means that the user can turn on and turn off the water tap by using a simple voice commands. In addition to the voice activations, this smart water tap also features a touchless operations, which made possible by a proximity sensors and a motion sensors. These sensors can detect whether the user's hands is within the range of the water taps and automatically turn on the water or turn off the waters. And this will make the tap more hygienic. Moving on to the temperature controls. This smart water tap is equipped with a temperature sensor and a heater, which allow the user to select his preferred water temperatures. By using the flow sensor and a motorized valve, the user also can adjust the flow rate to suit his need, whether he is washing the hands or washing the dishes. Finally, this smart water test also features a LED lighting that can be adjusted using a light sensors. The sensors can detect the ambient lighting condition in the rooms and adjust the brightness of the LED lighting accordingly. Let's move on to the second design concepts. Firstly, these design concepts also feature the touchless operations, which is made possible by the integration of proximity, motion, and hand presence sensors. Secondly, this design features an auto-moving taps, which means that the taps will move towards the user hands during the operations. Thirdly, we combine the soap dispensers and hand dryer into the designs, providing a complete hygiene solution in one device. Fourthly, this water tap also features the temperature control as described in concept number 1. Lastly, it has the leak detection feature, which uses the water leak sensors to quickly detect any leaks and use an alert system to warn the users. To achieve all these features, our water tap design includes various actuator components, including the solenoid and motorized valve, a dispenser pump, a dryer fans or heating elements, a heater, and an alert system. Finally, we come to the last concept, which is concept number 3. First of all, it has the touchless operation to ensure a more hygienic hand washing experience while minimizing the spread of germs as described in concept number 1 and number 2. In addition to the touchless operations, the water tap also features a soap dispenser which can dispense the soap into the water automatically during the hand washing operations. Thirdly, our water tap also has a warm or cold water mode that can be controlled by a temperature sensor and proximity sensors. Finally, to avoid the wastage of the waters, the water tap features the flow rate control and automatic shut-off features, where the tap will reduce the flow rate of the waters and turn off the water after a predetermined durations. Now we move on to the concept selections. To select the concepts, we decided to use the push metric evaluations to compare all the concepts, and finally we come out with the concept number 3 selected with the criteria such as the ease of use, energy consumption, durability, and maintenance requirements score positively and has the higher net score of 3 among the 3 concepts. Finally, we come to the design flowcharts. Let me use the real-life example to describe the projects. Firstly, if the user wants to select the cold water modes, he needs to move his hand to the left side of the water taps. Once the left sensor senses the presence of the hands, the cold water pump is activated. Now, the user needs to move his hand to the position under the water taps, where the proximity sensor number 3 can sense the presence of the hands. Once he senses the presence of the hands, it will open the valve and release the water. After the water is released for 5 seconds, the soap is automatically dispensed for 5 seconds into the water. Then, after 10 seconds, the flow rate of the water is reduced. And after the total runtime of 35 seconds, the tap is closed automatically. Thank you.
Hi everyone, my name is Bong Yi Wen, and I am going to present about the results or discussions in our cold water taps automatic systems by using the PLC. Okay, let's start. Now you can see from this diagram, it shows a general design of PLC ladder diagram of our automated water tap systems. I will introduce a little bit about each of the components and their functions. First, start and stop buttons are used to switch on or off of the whole systems. Sensors 1 and 2 are IR sensor, locating left and right to detect the motion and trigger the pump 1 and 2 respectively, while sensor 3 is located under a water tap, which is always normally closed. Pump 1 and 2 control the flow of cold or hot water, while valves allows the movement of water flowing from the water tank. Moreover, salt pump and valve control the salt dispersions, while closed valve controls the flow of water by reducing. Finally, timers are used to count down the time for each of the sequence, which I will brief later. For example, timer 1 will be count down for 5 seconds, and then the salt dispersion is allowed. Yeah. Okay, now we're going to brief about the results by applying the PLC ladder diagrams to simulate the cold water flow when the user triggers it. So first, once the start button is being pressed, the PLC ladder program is set to be activated. And now, when the user put his hands or her hands toward the sensor 1, which will be triggered cold water, so the sensor 1 will be activated. Then the sensor 1 will be active the pump 1, which will activate the main valve to be allow the cold water to be flow out. Then after that, the timer will be count down. After 5 seconds, the salt valve will be triggered to allow the salt dispersion. So from this diagram, you can see usually the start button will be normally open. Once it is pressed, so it show a green symbol, so it is being triggered, and followed by the sensor 1, also the pump 1. Sensor 3 is always normally open, normally closed, because it is the middle, is located at the under the water taps, so that a user can give the instruction from time to time. Go to the next slide. We can see after the sensor 1 trigger pump 1, followed by the main valve, it going into a 5-second countdown. After 5 seconds, it's being read. The salt pump will be activated. So at this moment, the salt will be dispersed to mix with the flow water, so the user can be wash his hands with the mix of the salt water. For another 10 seconds, 5 seconds, the salt bath will be stopped. That means the salt dispersion is stopped from evaporating or dispersion. And now we'll be going to 10-second countdowns. After that, the closed bath will be activated. Well, this closed bath is functions as control the water flow or reduce the flow of cold water after 10 seconds. After that, followed by another action is controlled by timer 4. Timer 4 will be countdown another 35 seconds, which means after all the cylinders will be activated, after 35 seconds, it will be stopped by deactivating the pump 1. Here you can see the palm one is off after 35 seconds is being count, then all of the things will be stopped. But if the sensor one is still on, that means the user is keep triggering the sensor one by putting his hand or her hand on that sensor. So they will recurse another repetitions of the similar law, which will be instructs the coworker to limit the same action same as the before, and the loop will be trying again.
For these sections, it will show about the result of flow of hot water using PLC feeder simulator. The results are almost same as cold water mechanisms, but manipulating by using sensor 2, which will trigger the pump 2 for the flow of hot water. If you have fully understood about this mechanism, you may proceed to the next sections. Otherwise, or you have still interested, you can also stay here for the further or more elaboration about this mechanism. For this section, I will brief about the business and also economic considerations on our automated water tap systems. And there are several aspects. I start with the initial investments. Firstly, we have to consider the investment involving in the research and development, design, and also prototype and testing before we decided to manufacture this kind of system and embed it into the various fields of our products. And also the next consideration is about the growing market demands. Due to the recent environmental issues and growth of the awareness under the communities, so it can be seen there is an increased awareness of hygiene and water conservations in public space years by years. And finally, we have to consider about the cost saving benefits, especially in the long run, such as reducing water usage and also the maintenance costs. Going to the economics considerations, it can be concluded that it shows positive economic impacts which can result in cost savings for both businesses and also public institutions. Apart from that, it also creates new job opportunities in various fields such as manufacturing, installations, and also maintenance. Moreover, it also has achievement up to 2 goals in SDG. First is about the good health and well-being. Our system can promote hygiene among communities and lead to prevention of spread of infectious disease since the hygiene level is secure. Finally, the cost of health care is reduced. Next, the SDGs about the clean water and sanitation is achieved by ensuring the sustainable water management and conservation. This can lead to cost savings, benefits for environments, and the communities.
Hi, I am Zi Neng and I will present on the part conclusions for this project. In conclusions, by utilizing feeder programming logic controller, the automatic water tap system was successfully designed. Pearce evaluation matrix was implemented to choose the best possible solutions for the automatic water tap system. Then, the main goal of this system is mainly to raise awareness among the society about the significance of the proper hygiene procedure while also achieving SDG 3 goals. Concept 3 was selected in this project as it has several outstanding advantages such as the lower energy consumptions and also less maintenance required for this system. Temperature control system become a key advantage of the project as well, as it has various temperature conditions around Malaysia. Then it offers users the options to choose the water temperature that is the most comfortable for them. And in conclusions, the hand hygiene is still poorly implemented in Malaysia and there's a need to use the practice of correct hand washing procedure as suggested by WHO. By making this system accessible in these locations in Malaysia, we can raise awareness about the importance of the importance of practicing the proper hand hygiene, which in turn can limit the spread of the infectious disease. Thank you for listening to our project presentations. Before I end my presentations, let me read a quote. Save water before it's too late. That's all from us. Thank you.